Hey girls and guys, welcome back. Today we'll be taking a look at scanning with Nmap, a very powerful network scanning tool. Go ahead and deploy your machine by clicking the green start button, plus starting your attack box by clicking the start attack box button in the top right corner. Task 2. When we are given an IP address or multiple IP addresses to perform a security audit on, we need to get an idea of the landscape we are attacking, or which services are running on the targets. How do we do this? By port scanning. When a computer runs a network service, it opens a networking construct called a port to receive the connection. Ports are necessary for making multiple network requests or having multiple services available. This is done by establishing connections to the remote web servers using different ports on your local machine. Network connections are made between two ports, an open port listening on the server and a randomly selected port on your own computer. Every computer has a total of 65,535 available ports. However, many of these are registered as standard ports. Some of these are: an HTTP web service can nearly always be found on port 80 of the server. An HTTPS web service can be found on port 443. Windows Net BIOS can be found on port 139, and SMB can be found on port 445. It's important to note, however, that especially in a CTF setting, it's not unheard of for even these standard ports to be altered, making it even more imperative that we perform appropriate enumeration on the target. Once we know which ports are open, we can then look at enumerating which services are running on each port, either manually or more commonly using Nmap. Nmap is the tool of choice for any kind of initial enumeration. Questions and answers. The third one, you need to go out to the internet and research to find the answer. Nmap switches. Nmap is run from the terminal. There are versions available for both Windows and Linux. Nmap is installed by default in Kali Linux. Nmap can be accessed by typing Nmap into the terminal command line, followed by some of the switches. Let's take a look at the Nmap help page. You can see the information and switches, the outputs, firewall evasion, timing and performance, OS detection, script scans, etc. And let's take a look at the man page for Nmap, if I can spell man. All the answers to the questions in task 3 are found within these pages, or these two pages, your Nmap help page and your man pages for Nmap. I'll take a look at the first ones with you. What is the first switch listed in the help menu for a SYN scan? I'm in the man page. I'm going to scroll down. As you can see, scan techniques. What is the first switch listed in the help menu? Well, it's there. And then if I had to go into the help page and check the exact same thing, scan techniques, the very first switch is hyphen little s capital S. That's your first answer. Second one, which switch would you use for a UDP scan? Here it is, right below that, SU UDP scan. If you wanted to detect which operating system the target is running on, which switch would you use? If you scroll down, OS detection, and there it is. It's a capital O or hyphen capital O. The rest are for you to work out and go through. Pay careful attention to the information shared with you and make good notes. Task 4. When port scanning with Nmap, there are 3 basic scan types. These are TCP connect scans, SYN half open scans, UDP scans. Additionally, there are several less common port scan types, some of which we'll also cover. These are null scans, fin scans, and Christmas scans. Task 5. TCP connect scans. TCP connect scans use the ST switch. To understand TCP connect scans, it's important that you're comfortable with a TCP three-way handshake. A TCP connect scan works by performing the three-way handshake with each target port in turn. In other words, Nmap tries to connect to each specified TCP port and determines whether the service is open by the response it receives. What if the port is open but hidden behind a firewall? Many firewalls are configured to simply drop the incoming packets. Nmap sends a TCP SYN request and receives nothing back. This indicates that the port is being protected by a firewall, and thus the port is considered to be filtered. Here you can see your TCP SYNAC and ACK three-way handshake diagram. There's your Wireshark capture showing the SYN ACK, and the ACK. If the port is closed, RFC states that. In other words, if Nmap sends a TCP request, SYN flag set to a closed port, the target server will respond with a TCP packet with a RST, which stands for reset flag set. By this response, Nmap can establish that the port is closed. And as we mentioned, many firewalls are configured to simply drop incoming packets. It's very easy to configure a firewall to respond with a RST TCP packet. Example, in IP tables for Linux, its simple version of the command would look like this. And this can make it extremely difficult to get an accurate reading of the target. Questions? There they are. And if you look into my terminal, I've got Nmap, the switch that we are discussing, ST, and my IP address, the output to normal, which I'm going to save, and I'm calling my file connect scan. I'm going to hit run. There's your results showing port 21, port 53, port 80, port 135, and port 3389 are all open with the different services: FTP, domain, HTTP, MSRPC, and MSWBT server. Task 6. SYN scans. SYN scans using the -s capital S switch are used to scan the TCP port range of a target or targets. SYN scans are sometimes referred to as half-open scans or stealth scans, where TCP scans perform a 3 full-way handshake with the target. SYN scans send back a RST TCP packet after receiving a SYN ACK from the server, without having to bother about completing a 3-way handshake for every port. SYN scans are significantly faster than a standard TCP connect scan. Advantages of this for us as hackers: it can be used to bypass older intrusion detection systems as they're looking out for a full 3-way handshake. This is often no longer the case with the modern intrusion detection solutions. It's for this reason that SYN scans are still frequently referred to as stealth scans. Some disadvantages to SYN scans: they require sudo permissions in order to work correctly in Linux. This is because SYN scans require the ability to create raw packets, which is a privilege only the root user has by default. Unstable services are sometimes brought down by SYN scans, which could prove problematic. if a client has provided a production environment for the test. All in all, the pros outweigh the cons. We are already root in our terminal, so we won't need to run sudo, but it's best practice to do so. I'm doing a normal output, saving it again, and I'm going to call this my root scan. You can name it whatever you like. My bad. While that runs the questions, there are two other names for a SYN scan. What are they? It's half open and SYN, which is here at the top. There you go. Question 2, can Nmap use a SYN scan without sudo? The answer is no. And then once again, there's the output of a scan that we've just run. Looks very similar to the one that we've previously run. And again, you can see it shows the ports open and what services are running on them. Task 7, UDP scans. UDP scans use the -s capital U switch, and unlike TCP, UDP connections are stateless. This means that rather than initiating a connection with a back and forth handshake, UDP connections rely on sending packets to a target port and essentially hoping they make it. This makes UDP superb for connections which rely on speed over quality. Example is video sharing, but the lack of acknowledgement makes UDP significantly more difficult and much slower to scan. When a packet is sent to an open UDP port, there should be no response. Nmap refers to the port as being open or filtered. Due to this difficulty in identifying whether a UDP port is actually open, UDP scans tend to be incredibly slow in comparison to the various TCP scans. For this reason, it's usually good practice to run an Nmap scan with the --top -ports and the number enabled, which you can see here as an example for you of that command. When scanning UDP ports, Nmap usually sends completely empty requests, just raw UDP packets. That said, for ports which are usually occupied by well-known services, it will instead send a protocol-specified payload which is more likely to elicit a response from which a more accurate result can be drawn. Calling mine a UDP scan, changing the switch out to a capital U, and there you can see output not show 999 open or filtered ports, and then it shows 53 port 53 UDP open, and it's a domain service. Task 8, null, fin, and Christmas scans. Null, fin, and Christmas TCP port scans are less commonly used. Here you can see I've already gone ahead and run my null scan. All three are interlinked and are used primarily as they tend to be even stealthier, relatively speaking, than a SYN stealth scan. Null scans are when the TCP request is sent with no flag set at all. As per the RFC, the target host should respond with a RST if the port is closed. Here you can see the RST in red, which it shows in the Wireshark capture. Fin scans. Here's my fin scan, which I've already gone ahead and run, which I suggest you do as well with the output. Fin scans work in almost the identical fashion. However, instead of sending a completely empty packet, a request is sent with the fin flag, usually used to gracefully close an active connection. Once again, Nmap expects a RST if the port is closed, which we can see again in the red, the Wireshark capture. And a Christmas scan. Christmas scans send a malinformed TCP packet and expects a RST response for closed ports. It's referred to as a Christmas scan as the flag that it sets. PSH, URG, and FIN give it the appearance of a blinking Christmas tree when viewed as a packet capture in Wireshark. Here's my Christmas scan, which I've already gone ahead and run. Practice, do it for yourself. That said, the goal here with the Christmas scans and the null and fin scans is firewall evasion. Many firewalls are configured to drop incoming TCP packets, to block ports which have the SYN flag set, thus blocking new connection initiation requests. By sending requests which do not contain the SYN flag, we effectively bypass this kind of firewall. Whilst this is good in theory, most modern intrusion detection solutions are savvy to these scan types, so don't rely on them to be 100% effective when dealing with modern systems. Take a look at the outputs that you get from Christmas scans, your null scan and your fin scan, and determine what information you're given back, as well as answering your questions. Task 9, ICMP network scanning. On first connection to a target network in a black box assignment, our first objective is to obtain a map of the network structure. In other words, we want to see which IP addresses contain active hosts and which do not. One way to do this is by using Nmap to perform a so-called ping sweep. This is exactly as the name suggests, ping sweep. Nmap sends an ICMP packet to each possible IP address for the specified network. When it receives a response, it marks the IP address that responded as being alive. For reasons we'll see later, this is not always accurate. However, it can provide something of a baseline and thus is worth covering. To perform a ping sweep, we use the -s switch in conjunction with the IP ranges, which can be specified with either a hyphen or CIDR notation. The SN switch tells Nmap not to scan any ports, forcing it to rely primarily on ICMP echo packets on the local network. If run with sudo or directly as a root user to identify targets, in addition to the ICMP echo requests, the SN switch will also cause Nmap to send a TCP SYN packet to port 443 of the target, as well as a TCP ACK packet to port 80 of the target. There's only one question. Hopefully you can work it out for yourself. There's the answer. Task 10, Nmap scripting engine. It's an incredibly powerful addition to Nmap, extending its functionality quite considerably. Nmap scripts are written in Lua programming language and can be used to do a variety of things, from scanning for vulnerabilities to automating exploits for them. The Nmap scripting engine is particularly useful for reconnaissance. However, it is well worth bearing in mind how extensive the script library is. There are many categories available. Some useful categories include safe, intrusive, vuln, exploit, auth, brute, and discovery. A more exhaustive list can be found here, which is the Nmap scripting engine, usage and examples. Go through this in your own time. Make sure you try some of these out. Read through, make good notes of what you're reading through. Questions: what language are NSE scripts in? It said Lua. Which category of scripts would be a very bad idea to run in a production environment? And that would be intrusive. Task 11, working with Nmap scripting engine. In tasks 3 answers, we look briefly at the -- script switch for activating NSE scripts from the vuln category using -- script equals vuln. It should come as no surprise that the other categories work in exactly the same way. If the command --script equals safe is run, then any applicable safe scripts will be run against the target. Note, only scripts which target an active service will be activated. To run a specific script, we would use --script equals and the script name. Multiple scripts can be run simultaneously in this fashion by separating them by a comma. Some scripts require arguments, example credentials they're exploiting, and if they're exploiting an authenticated vulnerability, these can be given with the -- or --script --args nmap switch. Note that the arguments are separated by commas and connected to the corresponding script with periods. A full list of scripts and their corresponding arguments can be found here, and if we go to it, you'll see that it's a reference portal for NSE scripts. Let me open that for you. You can have a look. There's a lot of scripts here in alphabetical order laid out for you. Go through it in your own time. Nmap scripts come with the built-in help menus which can be accessed using nmap --script -help and then the script name. This tends to be not to be as extensive as in the link given above. However, it can be useful when working locally. Questions: what optional argument can the FTP anon script take? To find that answer, go out to the document of NS scripts, scroll down until F, FTP anon, there it is. Click on that, opens up your script summary, script arguments, and there you can see FTP anon with .max list, and I believe that is your answer. Task 12, searching for scripts. How to find scripts. We have two options for this, which should ideally be used in conjunction with each other. The first is the page on the Nmap website, which contains a list of all official scripts. The second is the local storage on your attacking machine. Nmap stores its scripts on Linux at the user share Nmap scripts and if I ls to list the scripts, there they all are. Let me clear my screen. There's two ways to search for the installed scripts. One is by using the user share nmap scripts.db file. Despite the extension, this isn't actually a database so much as a formatted text file containing file names and categories for each available script. Let me see if I can cd into script.db. Let's take a look at the examples. Screenshot shows that they are in the user share nmap scripts, which we have exactly the same output. So if I type what they have, file script.db, you can see it says ASCII text, just like in the screenshot. It's always good to try and see if you can see or find the exact same screenshots as in the examples given. Let's do the second one, head script.db, and the output you can see is exactly the same. It's kind of scrunched because of the screen size, but I hope you can see that. Nmap uses the file to keep track of scripts for this scripting engine. You can also grep through it. You can see what they've got, so let's type that out. Grep ftp user share nmap script.db, and there you can see we have the same output as what you get in the screenshot. Another way, or second way, to search for scripts is to use the ls command to list them out. So let's try that. Let's go lsl. I'm just using tab to autocomplete, which helps to show that the files exist in those directories. And there you can see the output again with the file permissions, same as the screenshot. Note the use of the asterisk on either side of the search term, which was on either side of the FTP. And the last one you can try out with using grepsafe for yourself to see if you get the same output. Installing new scripts. We mentioned previously that the Nmap website contains a list of scripts, so what happens if one of these is missing in the scripts directory locally? A standard sudo apt update and sudo apt install nmap should fix this. However, it's also possible to install the scripts manually by downloading the script from nmap. Questions and the answers. If you followed along and you did exactly what I have done here, you should be able to find these two answers pretty easily. Task 13, Firewall Evasion. We have already seen some techniques for bypassing firewalls. Think stealth scans along with null, fin and Christmas scans. However, there is another very common firewall configuration which it's imperative we know how to bypass. Your typical Windows host will, with its default firewall, block all ICMP packets. This presents a problem. Not only do we often use ping to manually establish the activity of a target, Nmap does the same thing by default. This means that Nmap will register a host with this firewall configuration as dead and not bother scanning it at all. So we need a way to get around this configuration. Fortunately, Nmap provides an option for this. It's -P, which tells Nmap not to bother pinging the host before scanning it. This means that Nmap will always treat the target host as being alive, effectively bypassing the ICMP block. However, it comes at the price of potentially taking a very long time to complete the scan. If the host really is dead, then Nmap will still be checking and double checking every specified port. It's worth noting that if you're already directly on the local network, Nmap can also use ARP requests to determine host activity. There are a variety of other switches which Nmap considers useful for firewall evasion. The following switches are of particular note. It's -f, used to fragment the packets, making it less likely that the packets will be detected by a firewall or intrusion detection system. An alternative to the -f, but providing more control over the size of the packets, MTU or --MTU with a number accepts a maximum transmission unit, that's what MTU stands for, size to use for the packet sent. This must be a multiple of 8. Scan delay times, used to add a delay between sent packets. This is very useful if the network is unstable, but also for evading any time-based firewall intrusion detection triggers which may be in place. And -bad sum. This is used to generate invalid checksums for packets. Any real TCP IP stack would drop this packet. However, firewalls may potentially respond automatically without bothering to check the checksum of the packet. As such, this switch can be used to determine the presence of a firewall intrusion detection system. Questions? Pretty straightforward. Research the last one, going out to the internet if you have to. Task 14, practical. Use what you've learned to scan the target machine and answer the following questions. Does the target respond to ICMP requests? Guys, be careful with this question, it's tricky. I want to refer you back to an ICMP network scanning in task 9. One way to do this is by using Nmap to perform a so-called ping sweep. This is exactly as the name suggests, ping sweep. Nmap sends an ICMP packet to each possible IP address for the specified network. When it receives the response, it marks the IP address as being alive. 4 reasons we'll see in the task. This is not always accurate, however it can provide something of a baseline. So the way in which I received or I checked this answer out, I pretty much just did a straightforward ping to the IP. So if you know how to ping, let's go. And you can see it's not pinging. So that means you are not getting a response. So the answer is no. Perform a Christmas scan. I'm not going to do this, but I am going to show you that if I ls, all my outputs which are saved using the -O capital N for normal output, here you can see where I named my scans. Root scan, Christmas scan, UDP scan, and null scan. So the Christmas scan, if I want to see it again, I just say cat Christmas scan, hit enter, and there it is. Perform that. We've done it if you followed along. How many ports are open? Okay, it says 1000, but it's 999 in the answers. What's the reason for this? So the Christmas scan, let's just quickly have a look at this again. If I type and now I'm going to add in another switch, which is a double V, which is for verbose or very verbose. Let's have a look. So here you can see 1000 no responses. Host is up, received ARP responses, but there's the answers to your questions. Learn how to open up the Wireshark and captures. See if you can find the exact same Wireshark captures as the results that we've seen previously with SYN, SYNAC, and ACK. Deploy the FTP non-script against CAN login. If you go out to the scripting engine where we were, I'm at the FTP anon. Remember this script? I want to go back for you guys to see. When you searched for this, click on that. FTP anon opens this up. Example usage. There's your example usage. So it's SVSC. Deploy the FTP anon script against the box. Can Nmap log in successfully to the FTP server on port 21? Here you can see FTP on port 21 as the question asks, and then it says here FTP anonymous FTP logging is allowed. So can Nmap logging successfully on port 21? The answer is yes. Task 15, the conclusion. There's lots of great resources for learning more about Nmap on your own. Front and center are Nmap's own docs, which have already been mentioned several times throughout the room. These are a superb resource. There are more upcoming Nmap rooms within the TryHackMe, which showcase more of what we've just learned. Plus, the other rooms showcase different techniques and in-depth dives about commands, adding to your already Nmap arsenal. Make good notes, always. See you in the next videos.